Do you ever find yourself wondering how scientists can be so sure that the Earth is 4 billion years old? Given that the humans only existed for a few million years, how could they possibly have knowledge of it? The reason is simple: rocks. Rocks are especially useful for helping geologists determine how ancient an object is. Through the study of meteorites and the dating of rocks in the Earth's crust, they were able to determine the age of the planet. And while determining the age of the planet, they created in what you could call the calendar for events in the Earth's history. This is what is called the geological timescale. The earliest geological timescales simply use the order of rocks laid down in a sedimentary rock sequence, also called stratum. With the oldest at the bottom, there was no specific dating attached to the sequences, and were simply labeled the oldest to the youngest. It was only after Charles Darwin's publication Origin of Species in 1859 that geologists realized that particular fossils were restricted to particular layers of rock. This built up the first generalized geological timescale. Only when radioactive isotopes and subsequently absolute dating were developed in the early 1900s could igneous and metamorphic rocks be dated for the first time.
So, what does absolute dating mean? Absolute age is the process of determining the numerical age or range of a layer of rocks or fossils. Absolute age can be determined by using radiometric dating. Absolute dating methods measure the physical properties of an object itself and use these measurements to calculate its age. One of the most useful absolute dating methods for archaeologists is called radiocarbon dating. It works by measuring carbon isotopes, which are versions of the element carbon. How does it work? The primary methods of absolute dating involve using the radioactive decay of elements trapped in rocks or minerals, including isotope systems from younger organic remains to systems such as uranium. The atoms of some chemical elements have different forms, which are called isotopes. These break down over time in a process scientists call radioactive decay. Each original isotope, called the parent, gradually decays to form a new isotope called the daughter. Each isotope is identified with what is called a mass number. When parent uranium-238 decays, for example, it produces subatomic particles, energy, and daughter lead-206.
The amount of time that it takes for half of the parent isotope to decay into daughter isotopes is called the half-life of an isotope. When the quantities of the parent and daughter isotopes are equal, one half-life has occurred. If the half-life of an isotope is known, the abundance of the parent and daughter isotopes can be measured, and the amount of time that has elapsed since the radiometric clock started can be calculated. Isotopes are important to geologists because each radioactive element decays at a constant rate, which is unique to that element. These rates of decay are known, so if you can measure the proportion of parent and daughter isotopes in rocks now, you can calculate when the rocks were formed. Because of their unique decay rates, different elements are used for dating different age ranges. For example, the decay of potassium is 40 to argon 40 is used to date rocks older than 20,000 years. And the decay of uranium 238 to lead 206 is used for rocks older than 1 million years. Measuring isotopes is particularly useful for dating igneous rock and some metamorphic rock, but not sedimentary rock. Sedimentary rock are made of particles derived from other rocks, so measuring isotopes would date the original rock material, not the sediments they have ended up in. Sedimentary rock is best dated with relative dating. Going back to the geological timescale, the relative geologic timescale developed from the fossil or rock record has been numerically quantified thanks to the dates obtained with absolute or radiometric dating methods, and is much more accurate now. So this is how absolute dating was used to determine the subdivisions of geologic time. Let us all say a big thank you to rocks for telling us the history of the Earth.